Hello. So today we will verify the superposition theorem. This theorem states that if we sum up individual contributions of each sources in a circuit, we will get a total response. For example, we have this circuit and we want to find out the value of current I3 flowing through R3, and we will obviously use the superposition principle. So what we will do is we will keep alive only one source, which is, let's say, E1, and we will kill E2, so we make it 0 volt. So this becomes 0 volt and this becomes a single wire. Now we will calculate the current flowing through R3. Let's say we get I3 equals some value and we name it I31, some value. Next, we will do the same for second source, which is E2. We'll keep this alive and we'll kill the first source E1, make it 0. So this whole thing becomes a single wire since it's a 0 volt, so no voltage difference. And we will measure the I3 again flowing through R3. And now let's say we get I3 2, which is another value. So the superposition theorem says that we will get total I3 if we add up these two individual values. So total I3 is the total contribution of both the sources together. So that's the full principle. Let's see in our simulation software. Simulating the circuit in Proteus, I will need 3 resistors and 2 voltage sources. As this is your fourth lab, so I will not go through the tiny details. So bear with me. I need the resistors. Yeah, this one. And I need battery. Okay. So let's put the batteries first. And the resistors. I want to rotate this. Okay. And I will need an ammeter to measure the current. So I'll put this here. Okay. And another thing is I need a ground for my circuit. So these are all my components. Now I have to connect all this. Now let's give values. This is 400 ohms and this is 500. This is 700. These are all arbitrary values I am giving. So when you do your report, you will get specific values for R1, R2, R3, and you have to simulate that accordingly. Now I'm just doing a random circuit. So I'll keep this 10 volt and this one 20 volt. So my circuit is complete, and so in this circuit I want to apply the superposition principle, and for doing that, keep one source alive. So let's keep E1 alive, and I will deactivate source 2. So for deactivating that, I am making this 0 volt. So now my circuit, so in my circuit now, the second source is deactivated. So by making this 0 volt, so no voltage difference, and only my source 1 is active. So the current I will get through in this ammeter will be the solely specific contribution of source E1. So let's see what we get. Oh, we need to change the range to milliamperes now. So yeah, this is 6.02 milliamperes. So yeah, milliampere. So I31 for the source 1. Now I will kill my first source. That means I will make this 0 volt, and I will restore the value of second source 20 volt. So now first source is inactive and second source is active. So the current I will get now will be the contribution of only the second source. Let's see what we get. Yes, we are getting 9.64 milliamperes. So I32, the contribution of second source is 9.64 milliampere. So according to superposition theorem, what we expect? We expect the value of I3 to be the sum of these two, which will be equals to 15.66 milliampere if I sum both. So for doing that, I will restore the value of first source to 10 volt. See, my circuit is as it was in the beginning. Now when I measure through the ammeter, the current will be the total current going through R3 when both the sources are active. Yes, I have got 15.7 milliamperes. So that is 15.7 milliamperes. Why I have got 7 and 6 here? Yes, the result is rounded. So thus the superposition theorem is hence verified and proved here through circuit simulation. That's all for this lab. Thank you.